Sorry about that. Sorry for that inconvenience. We are going to change the order. Meanwhile, Alexis will come to try to fix that. And Federico Nenibaji will be the next speaker. Thank you very much, Federico, for being here.
Thank you.
Thank you.
Thank you for having me here. The work that I will present is exploring local well-being and vulnerability through OpenStreetMap, a case studies from Italy. This work move on from gaps finding in the resilience literature. First of all, I read a lot of definitions of resilience, a lot of indicators, but most of that indicators are referred to national scale or comparison across countries. It is more difficult to find indicators for sub-regional scale, and the other gap that we find in literature, resilience literature, is related to the typical time interval suffered by traditional statistics. So we move on from these two gaps in order to try to give a contribution to solve these two gaps. And our idea is to explore new databases in order to find new data available for the creation of indicators and for the estimation and prediction of well-being at sub-regional scales and more granular scales, territorial scales. So we identified OpenStreetMap as a possible data set in order to solve this problem. Again, these are the reason and the motivation and the gap found in literature. Why to take into account Italy? First of all, just because I'm from Italy, so I'm from the University of Macerata, so we are more confident in using data from ISTAT, that is the official statistical office in Italy, and also for another reason, that one related to National Recovery and Resilience Plan, implemented by all countries across Europe after the pandemic crisis. And in Italian national and resilience plans, 87 billions are related to projects that has to be developed from local government entities, from municipal, regional or provincial government entities. So also local institutions needs new way to monitoring, define and evaluate projects at the local level. The analysis that I will present next move from two works, these two works, the Feldmayer and others of 2020 and the Wojcik and Andrews 2022. Both of the work use machine learning methodologies such as the lasso regression that I will use in my work, and others related to random forest or neural networks in relation to OpenStreetMap data and remote sensing images in order to evaluate the well-being at a local scale. In the first one, for Feldmayer and others' work, they try to predict from OpenStreetMap data's socioeconomic indices at municipal level for a region in Germany, and in the other work from Wojcik and Andrews, they try to evaluate well-being indicators for the Warsaw city in Poland. So the main hypothesis of this work is that inside OpenStreetMap data there are proxies useful to predict and evaluate well-being at a local scale. This hypothesis move from the idea that OpenStreetMap data have inside of them the human activities on the territorial level, on the maps. So, what is OpenStreetMap? OpenStreetMap is I like to describe it such as a combination of Google Maps and Wikipedia. Google Maps, just because it's moving from a map, is a map, but is a map not provided from private companies, such as Google with Google Map, but is provided by users. So it's freely contributed by users. There are almost 10 millions of registered users in OpenStreetMap, but at least the 1% actively contributed and actively provide the most of contribution. So the Wikipedia part of OpenStreetMap is that one. Users can fix it and pointing human activity on the map, openly and freely. This is the strong part of OpenStreetMap, just because it's open and you can download data freely. But it's also the main issue related to OpenStreetMap. Just because it's open. Contribution is not homogeneous. So a lot of work has finding that there is a sort of gap, a sort of trade-off, a sort of heterogeneity between rural area contribution and urban area contribution from users. So urban area are more mapped, more contributed respect to the rural ones. Our methodologies is want to move only from data. It's a sort of data-driven methodology. We want to look at which kind of mapped point of interest in OpenStreetMap are correlated to the statistical official well-being indicators. So we counted for all the 103 provinces in Italy the number of 128 categories that are mapped in OpenStreetMap, such as hospitals, restaurants, bar, all human activities that you can imagine, bus stops, train station, whatever, military establishment, universities, schools, whatever. And we counted for the 103 provinces in Italy that refer to nearly 58 million people in Italy. So the first step was to count all these categories from OpenStreetMap for each provinces. And then we decided to reduce the number of categories to 60, putting together similar categories from OpenStreetMap. So for example, you will see the categories food and drinks. That is the union of restaurants, bar, pubs, and whatever is referred to this kind of services. So at the end, our dataset contains 103 lines, each one for each provinces, and 60 columns, that is one for each OpenStreetMap categories counted. All values are normalized per 5,000 inhabitants in relation with the population of the provinces. Our methodologies use two kind of regression, two kind of methodologies. The first one is the lasso regression, a regression that is also able to produce feature selection automatically using a penalizing parameter that put to zero the not significant coefficients. And the other one, in order to minimize the risk to overfitting, we use, due to the small data set that we have, we use k-fold cross-validation with 10 folds. In this way, in this kind of methodology, divide the sample, the data set, in 10 folds, and repeat the process of estimation, testing each time the regression on a different sample, on the different subset of the data set. So here you can see the variables that we compare to OpenStreetMap categories, that regress with respect to OpenStreetMap categories, and they are put in a table in decreasing order for R-squared, our measure of performance of the model. So in brief, we can see that economic dimension indicators, official economic dimension indicators, are the best one predicted from OpenStreetMap categories, followed by innovative environment indicators such as propensity for patents, high-speed infrastructure, internet infrastructure, and we see lower level for performance in relation to environmental aspects such as the availability of green urban areas, public transport, and waste collection. You can see all the target indicators that we have used in this table. We look at which kind of categories are performing and are more used by the model in determining, making prediction. And we can see this one from this table, these images, related to variable importance. Variable importance tell us which variable is most used in determining the prediction from the model. So in this case, for the youth employment rate, we can see that the highest variable importance is related to the number of train stations per 5,000 inhabitants, followed by land use industrial, so the area mapped on OpenStreetMap has industrial areas, land forest, so the area mapped on in OpenStreetMap as a green area, forest area, and so on. But from these kind of images, we only know the magnitude of the effect in the prediction from each variable used. In order to understand the sign of the relation between each OpenStreetMap categories used for prediction respect to the target indicators, it's better to use the coefficients terms directly from the lasso regression. So here we display some examples for the indicators that has the highest R-squared values, so they have better performance, the best performances. So you can see OpenStreetMap categories with positive sign are related, obviously, positively to the prediction of the value of the target value, and negative sign are negatively correlated. It is interesting. Also here you can show. We show two examples of maps. You can also put in maps this prediction and making confront. Here on the left-handed, you have the real values. The real values used from ESTAT indicators, and on the right side, you have the prediction made by the model respect to the same indicator. This is the most interesting case that we found, most interesting result that we found, is related to the betting agency, to the gambling agency, to bookmakers agency. So among the categories counted in OpenStreetMap, we count also the number of bookmakers agency in each provinces. And we normalize it obviously for 5,000 inhabitants. And we found that it's always selected by the lasso regression respect to the main economic indicators that we use. And there's also a coherency in the sign in which the bookmakers variable come into the regression. For example, related to employment, to the youth employment rate, it enters with a negative sign, a negative coefficients. The same things happens for average disposable income, and also for the for the youth unemployment rate, we found a positive sign. Also, for example, for NEET, we found a positive sign, and then also for inadequate literacy competencies, or for the share of children using child services for the year 2029. Here we display all the correlation between the indicators and the single variable bookmakers, and we can find that the signs are the same and coherent with the economic theory, and all our values are significant at the statistical level. So these results is coherent also with other works that use different methodologies that relates betting and gambling games to poverty and to vulnerability of subset of population. So other works found that area with people that are poorer, that are unemployed, that has not a higher level of education, tend to use more these kind of services, such as gambling, sports betting, and new kind of betting. And this evidence from literature confirm our correlation. In fact, again, for example, the number of NEET increase when bookmakers' value is higher in provinces. So provinces with a higher number of bookmaker agencies shown a higher number of NEET. Again, a higher unemployment rate is correlated positively with a higher number of bookmaker agencies.
Do you think that the causality is
No.
that way?
Yeah, that's a good point. We are not talking about causality. We are talking just about correlation. So this kind of data-driven processes, this kind of analysis would be a sort of instruments where you don't have available data, official data, in order to evaluate monitoring vulnerabilities or the well-being status of territory. Okay, but we are not saying that if you close all betting agency in Syracuse provinces in Sicily, you will immediately see a higher number of employment. Yeah, it's not that the conclusion. The conclusion is that if you don't have data and you need to find which are the provinces or territory, we will see next the scalability of the method. You may use, if you don't have official data, OpenStreetMap data to see which kind of territories are more vulnerable. Okay, I hope I explained to your question. So the other key point is, okay, we have done this analysis at province level just because we had an official value, an official indicators, and we try to predict the values using lasso regression. But what about the scalability of the method? So it is more common that at sub-municipal level we don't have official data. Also in Italy, usually for municipal level data are not usually available. So what about the possibility of scaling, scalability of the method? So we try two case study. The first one is to predict at province scale and for a sample of 2,000 municipalities of Italy, the same target variable that was pre-tax income. And those are the results. We can see first of all that the R-square measure, the performance model measure, goes down from 0.7 at province level to 0.06779 for a municipality. So we lost accuracy and performance from province scale to municipal scale. And then the lasso regression made at two different territorial scale produce some differences in the selected OpenStreetMap categories. We can find same categories, but also we lost, you can see from the number of selected category, lot of them. In the end, we have a positive note from this case study that is again the bookmaker history, the bookmaker story, narrative. Just because, once again, bookmakers, respect to this monetary target indicator, was selected but at provinces level, but not at municipal level. The other case studies, in order to try to see the scalability of the method, the possibility of scalability of the method, is that one. We use Rome municipality, sub-municipal, called municipi, neighborhood, large neighborhood in Rome, okay, that are called municipi in Italian, and we compute the lasso regression at provincial level for the unemployment rate, and we use the coefficients estimated at provinces level to the sub-municipal values for Rome. Okay, it's clear, this one? Okay, so we use the estimated coefficients at provinces level for unemployment to the data for Rome. And those are the results. So the first column is the real value of unemployment in Rome, in the sub-municipal district of Rome. The second column are the predicted value using the coefficient estimated at provinces level, and then we compute the rank, just because we are not interested properly in the exact estimation. But if you need to, as a policymaker, to spend some European fund, for example, to the most vulnerable district of a city, you need not the exact prediction, but you may need probably a sort of rank of which are the districts that are more vulnerable or more poorer, or where the unemployment is higher. So we produce also for actual value, for real value, from predicted value, the rank, and we look at the differences among ranks, and we see that for most of the district of Rome, there are few change of positions, and only for 4, the red ones, district of Rome's 3, sorry, we see that there is a larger change of position, and this is made probably due to the different composition of districts in Rome. For example, the 8th district in Rome is that one that presents the higher change in rank position, is the larger one in Rome. It has the higher value of population, and it also starts from the city center and end at the periphery of the city. So probably due to the heterogeneity inside the district, we lost the ability to predict a good value. Again, we made this analysis just because we have the real value for Rome district of unemployment to compare to. If we will have values for lower little district, we may do the same analysis and probably try to have a more robust analysis. Yeah?
You mentioned that the bad prediction for this district is because it's too big, so it's too heterogeneous.
Yeah.
But when you define units at the province level, are not these units also very heterogeneous?
Yeah, for sure.
More?
But we use 103 provinces, and we try to minimize the overfitting problem using cross validation, and the predictions are made on the same data sets. Here, talking about scalability, I think that these kind of problems for only 15 observation became explode. Okay, so I would like to try to implement this scalability case study to more observation and to lower heterogeneity units. I hope I have an answer to your question. No. Yeah, no, you're right about your observation, for sure. But at provinces level, for example, the north-south difference, the north-south inequality that is usual for Italy at all economic level is confirmed from also from the prediction model. This is talking about it. Also, the model taking into account the differences of north and south economies of Italy. Just using the counting of economic activities taken from OpenStreetMap. But at this level, I cannot say the same, just because we don't know inside the 8th district of Rome how much is the variabilities of unemployment from that one sub-district closest to the city center and that ones that are far from the city center.
Yeah, but you still know how many train stations you have in this district, or?
Yeah, but I don't know where they are. I just counted that. So I don't know if they are all at the periphery or they are uniformly distributed across the district. So in order to solve this argument, this issue, we should know to divide also inside the 8th district of Rome. I go briefly to conclusion, but we've just talked about that. One is to have we would like to have more possibility to test the scalability of the method and exploring local well-being through OpenStreetMap data suggests that there are potentials inside this kind of data, but we have to take into account data quality issues and most important things. We have to try to analyze better the scalability of the method, just because this instrument will become important probably for policymakers only if the method will be scalable. Okay, thank you so much for your attention. Yeah.
So,
Thank you very much.
Yeah.
Sorry, please.
Yeah, thank you for the presentation. I have a question about your target variables and actually the frequency of your data. This is what? This is spatial? Sorry, this is cross-sectional analysis?
Yeah.
Yeah, it's just cross-sectional
not temporal
analysis.
consideration. Also the temporal modification and analysis will be a study to do. Yeah, just because to see the variation of OpenStreetMap respect to the variation of the single target during time. Yeah, it will be absolutely interesting to implement.
Right. And which are your target variables here? Which are target variables?
All taken from ESTAT. We try to take into account a different dimension, from economic dimension to social dimension to innovative environmental dimension and to environmental and sustainable dimension. So, for example, the need, the average per capita assets, the average per capita income, inadequate literacy competencies, so the concentration of PM10 in the waste recycling percentage, crimes, beds in hospitals, urban green availability, but all of that are taken from ISTAT, so the official statistics office from Italy, and then we try to predict them using OpenStreetMap categories.
And all these data are at the province level?
Yeah, for sure. Yeah. All that at the province level, yeah.
And then you go to the OpenStreetMap and then you basically take as many data as you
As I can, yeah,
at
exactly.
a specific year, that's specific the same year.
Yeah, not at the same year, at 2022.
Okay.
Yeah, just because not all of data are available, as you can see,
Okay.
at the most recent. And this is one of the gaps that move our research moving on. Just because also for a provinces level, e-stats don't display as open source data as most recent as possible.
Interesting.
Well, I'm going to do the discussion because I was supposed to lead
Okay.
the discussion, so, okay. Well, the topic is very interesting, so congratulations, because I think that in terms of data collecting, we should move in this way. But at least after reading the paper, it's not really clear to me. Obviously, you mentioned that the intention is to get the statistics from those geographical units where the statistics are not available, okay? But what I think that the exercise you do is fine if you can have a standardized method that allow to use this in Italy, in Germany, but also in Mozambique. So this is the whole thing. For instance, when I look for related literature as the one that uses satellite,
Yeah.
well, this is only things to think about because I'm not an expert, so let's give my impression after a quick reading. What my feeling is that when they use these satellite images, okay, they have a very specific method where, for instance, the images, depending on the type of roof, the size of the etc. So they create 3 dimensions, and from these dimensions can predict an income level. Okay, and this is good because this works for Liverpool, this works for Medellin, and this works for many cities, with some differences.
Yeah.
But I say that they at least provide a reliable
Yeah.
measure in areas where there are no statistics. My point is, well, I mean, it really, I mean, are there, for instance, in developed economies, so many countries where you cannot have, for instance, available data at a municipal level? So I think that you should work more in a standardized method that allow us to use this. Okay, so this is my first. But the other you already mentioned some of this previously in my last question. But what you count the number of points of a specific activity. But what you may have 2 municipalities with the same number of points, but with a totally different distribution. Like you may have these bookmaker agencies in a specific neighborhood, okay? And so I think that is something that you should find a way to deal with that.
Yeah.
Some kind of, say, not only the number, but also the distribution, okay? This is, otherwise, I think that this is not really informative, this number, okay? Is that, okay? If you teach statistics, you just teach the mean, and then it's not really explicative. So the other thing is that the methodology, okay, that, well, this is standard regression. Obviously, as here, as an economist, we are kind of slaves of causality, you know. Then for us, all these methods that only look for prediction, but they are not really interested on because indeed most of your indicators are not the cause.
No, absolutely.
But probably are a consequence of,
that's it.
of that. So, but I understand that it's not always causality is the important thing, but what happens if the correlation you have is spurious?
Yeah, that's a good point.
You know, because I have a clear in my, so something that was really interesting is that you have that your model performs very well for the youth unemployment for 2020, but not for 2021. The R square for 2020 is 0.7, and the R square or 0.8 and the R-square for unemployment rate in 2001 is half, 0.4. So if you have a methodology that for the same magnitude, with only 1 year of difference, provides so much different performance, this means for me that it's not reliable. Now, in the state that it is now. So this is something serious because I don't think that from 1 year to another year, any of the variables change so much. So the other point is I'm also, well, just in terms of presentation, that this is something very common in PhD students. Don't try to show all the tables one slide, okay? Just make a selection and make that anyone can see the number, because otherwise it's difficult to follow. Regarding the scalability of the method, that this is a key point. Okay? This is one of the most important things. But the fact that your R-square for provincial level is 0.7 and for municipal level is 0.07, I think that is a serious problem. And also cast doubts, serious doubts about the reliability of the method. Because first, this methodology, I think that is relevant at the municipal level, not so sure if at the province level is so relevant, and even at the neighborhood level is even more. So, indeed, for instance, the fact that your key variable that is good makers, for me is a clear proof of that, because this variable disappears. Yes. So, I mean, your main key indicator cannot disappear just when you change the level of aggregation. This is I think this is a serious concern. So, for me, what is the interesting thing is, because you do this prediction, but I think that the most important thing you should do is to test the reliability of the method. You should take the most, say, the smallest geographical unit, okay, for all your available data, and you have to make sure that the distribution of your variables in this OpenStreetMap does not change so much when you aggregate. And probably this problem is because the distribution of your OpenStreetMap variables at the province level is totally different than the distribution at municipal level. So, and this is something that you should, because you should choose a, let's say, geographical aggregation where the change from the minimum aggregation does not change so much. So when the distribution starts to change, then you have to stop. That's because otherwise it's not reliable. I mean, you cannot use a method that if it is municipal, is reliable, if this province is reliable, but municipal is not reliable, or if it's regional, or so. That's
it's so. In order to try to answer,
my last one. So
in order to try to answer to your comments, all the comments that you made, in my opinion, can be expressed with the term of scalability of the method. Just because we are talking always about scalability from municipal level to provinces level, from 1 year to another year, so also from the temporal side. And that's it. But as, in my opinion, as policymakers and as academics, we need data, and usually we don't have data. So that one was the first try, the first experiment to explore the possibility of use of this kind of data. And there are a lot of issues, as you said, and there are also a lot of possibilities in order to try to go deeper in the theme. But in my case, the main issues was the availability of data. Just because talking about neighborhood level, I cannot find any data to calculate the model at that scale. So I use the lowest scale that I find I find official data, a large number, and a number of target that comprehends a lot of dimensions, and try to produce the analysis. At this level, I think that the results, the evidences are good. Just because, as for the bookmaker evidence, it is always significant and coherent in the sign and of the relation with different economic indicators, all related usually to the economic dimension, but with different indicators and also for different years. So you have here the unemployment rate at 2021 and the need at 2020. So respect, for example, to the temporal variation, bookmakers, the evidence of bookmakers, it's robust, not at all, but the first evidence is about the robustness of this kind of evidence. But when we move to the other scale, we lost that evidence. So also, I think that I start with an idea, with a sort of hope, in order to have an easy scalability of the OpenStreetMap, and I find this kind of results, but I have to put it in just because I move only from a data-driven process, a data exploration of OpenStreetMap data. So it's good, even if not the best, to show that at the moment, for the first evidences, moving from provincial scale to municipal scale, it's not possible at all. But better evidences in terms of scalability possibilities may appear for looking at, for example, at ranks at district level inside of Rome municipality. Consider that the 8th municipio district of Rome is larger in terms of population than the 80% of municipalities in Italy.
Yeah, sometimes to create...
so in terms of population, is larger than provinces.
Yeah.
Also from my hometown provinces. So,
but what I mean is that if you want to create a kind of a standard method. Standard method,
yeah. Your first comment, yeah. For example, remote sensing and satellite images are more standardized, but there are evidences that deep neural network, convolutional neural network implemented on a training data set of images from Europe does not fit to developing countries in terms of identifications. So also remote sensing has all empirical analyses has the issues of how are the training data sets. All depends from training data sets. If you put in your remote sensing training data sets also images from Mozambique, the model will identify also that kind of structures of part of the city. But if you put only Paris remote sensing images, the model cannot perform on Mozambique. So I agree with you, and again, all depends on the availability of data. For sure, start looking at these results, we can conclude that per-income tax determinants are not the same at provincial scale respect to municipal scale. So there is not the possibility of scalability of the method. Yeah, that's it. But in the end, I think that all depends from data that we have and the possibility of work with that. Okay.